Good morning. Sorry for the slight delay today. We are happy to present our lecture number 9 about location-based social networks, demographic prediction, and user mobility analysis. So let's kick in and let's discuss these exciting topics. We'll talk about location-based social networks, so just recall about that. We'll talk about human-urban mobility. We'll also talk about recommendation systems that can be done based on location-based social networks, a bit on demographic prediction, and what is this mixed demographic mobility is. There are several references. The first paper is actually by our group, and there's also 2 more papers by Nolas. Nolas is quite famous researcher in this area, and by Paulo Rosso for the PAN competition, paper number 3. Okay, so location-based social networks. Is it social networks where people, as you can see from the name, share their locations, not just let's say post, but also they share their location data. And location-based social network is pretty much now a part of other social networks that has been created originally as not location social networks. So basically, this location feature, the opportunity to share the information about every place where you have visited, you can actually have this opportunity even in some other social media. So examples are, of course, Google Plus, Gawala, Facebook, Ramo, Foursquare. Foursquare was one of the first social network that has been originally created as location-based social network, and others. Another called Dodgeball, for example, quite many. So if you look into the whole market, the main player will be Foursquare as a purely location social-based social network. And you can see this quite beautiful heat maps that has been created based on location-based social networks like Foursquare. So, for example, this is a visualization of the city, how the city get changed over time, right? So, this is a visualization based on check-ins. So, actually, this location-based social network can be very powerful in terms of telling where people go from where to where they travel, what they do, where they active. You can build a very beautiful social maps, and you can see that in the left side, in the left side, there is quite important indicator that is talking about the place where people are visiting. So you can see so about 10 a.m., 11 a.m. Many people go to foot, and you don't have residents people, and people are doing shopping closer to evening. Some people go to outdoors in afternoon, and then closer to 9 p.m. People go for food again for the residents. Then people go less for food and more for residents 2 a.m., 3 a.m. And then closer to 5 a.m. there's just check-ins that generally disappear, right? So what does it mean? It basically tells us about 2 things. The first one is that location-based social network are not just locations, not just longitude and latitude, but also about talking about the semantics of the place that the person visits. And also at the same time, of course, another important factor of location-based social network is that you can see the changes of the locations over time. So it's like the so-called temporal aspect or longitudinal data. And this data is very, very valuable because you can see how preferences changed over time. And this availability of this data has raised lots of research around this. So check-ins are multidimensional. We have a social component, the geographical component, temporal, longitudinal component. We have a mobile component. And if you look at a typical check-in page in Foursquare, you'll see that there is also geographical location. There is a place types of the place, like Foursquare recommends the venues where to go, and this become actually pretty much the main business model for Foursquare in the last days of its existence. And you can also add friends, so it's a typical social networking, social graph features, and you can have friends feed, communication, and all the typical aspects that you can see in any general social network. So, Foursquare user might, for example, take a check-in somewhere, may get some uh, friend comments and friendships. Foursquare user could also see what are the key trending locations around there. And of course, this is a great avenue for us to really discuss and see how locations get used, where people are going, and what they're doing everywhere. So if you look at a global distribution sample from Foursquare venues, you can see that the red areas are those places where a number of check-ins has been more than 100. Green areas are less than 50, and blue is less than 10, and less than 50, right? So basically, you can see that where Foursquare was popular, it was popular mostly in the uh, North America, a little bit in South America as well. It was popular in European side, and a little bit in Russia, and also some of the Asia countries. So this map pretty much shows you how the location-based social networks are popular, where they are popular, and development of social network as well, in a sense. So now, what can be the applications? You can actually try to do a cross-region type of research where you want to learn from one region and then recommend to people in another region where they want to go, what they want to do there, right? So there's a couple of research papers devoted just to this. You can actually learn your preferences in your home country, figure out what is really relevant to you in some other location in some other country, and then uh, do such a multimodal recommendation for you where you want to go in another location, what you want to do there, what you want to visit there, in order to really help you to have a better experience, visit more interesting places to go. So, for example, can be what was done can be done from one location to another. For example, from Singapore to London. So we'll be talking about human urban mobility in 3 minutes time. So, well, let's talk about human urban mobility. So basically about how people move in urban environment. So why in the first place you want to study human urban mobility? We want to do urban planning. We want to understand the city and optimize the services, optimize the facility arrangement. It's very important application in public service point of view. But also we want to recommend people where to go so we can improve the user experience of our social network. We can provide some additional services. We can do some marketing and advertisement based on the mobility traits and studies in a particular city. So it's very useful, and it has been addressed as far as in 1800 by William Farr, by Ernest George Bernstein. It's a number of scientists that were basically busy with this topic. So William Farr was basically thinking that human migration doesn't have any particular flow, but there were first ideas that uh, that there could be some definite rules, or there could be some traits or events that actually define how people migrate, and those trends might really be making sense. So, following standard list of universal proposal in 1880s, there were several theories. The first one, that migration flow generates return of homotonic migration. Majority of migrants move a short distance, while the minority long tail move a long distance. Those who move long distance usually choose the bigger cities because, I mean, basically people have to reason, right, to move to long distance. Residents are often less migratory than inhabitants in rural areas. Families are less likely to make international moves as compared to young adults. Most migrants are adults, and towns grow by migration rather than by natural increase, right? So this is how it works, and I think most of these laws you probably can witness by yourself, even for ITMO University. Some of you have came from other parts of the world, or other parts of Russia, and that sometimes was quite a big distance. So why is the reason you want to come? Is because you want to make sure that you're travel for opportunities, basically, right? So most of these roles have been um, proved, right, even nowadays. So Rubinstein exploited census data from the United Kingdom and some empirically supported his findings, right? So basically, he found this and he supported it from the empirical observations. Then Samuel Asthofer came with a so-called intervening opportunities model, and he basically gets inspired by the so-called gravity models from physics. So he said, okay, maybe people are not physical particles, but so precise model is necessary, right, to figure out how they move. So basically, there's one location, there's another location, and in between these locations, there are opportunities. And he empirically proved the number of persons going given a distance is directly proportional to number of opportunities at the distance and inversely proportional to number of intervening opportunities, right? So basically, people considering distance, but also people need to have a reason why they move to certain distance. So, for example, you are in one city, in some smaller city in Russia, let's say, and then you want to move to Moscow. You always have opportunity to maybe move to a nearer and bigger city rather than move all the way to Moscow. And then depending on how much interesting for you to move to particularly Moscow and how comparable is the experience of the nearest big city, you might decide to move to Moscow or decide to move to a nearest big city. For example, this nearest big city can be St. Petersburg, and the city you are from could be, for example, Vilberg, right? So it's near to the border to Finland, and you can decide, right, whether you want to Moscow all the way, or you want to move to St. Petersburg because, let's say, ITMO University is already quite good university for your studies in computer science. You probably don't want to go to Moscow universities to do so. So this is how it works, and this is was studied in how American families were moving in Cleveland. So there is also the recent study was done uh, by the scientists in the U.S. They had $246,000 notes, and these notes were monitored, and they were monitored through the specially created web page. Where you can go to this web page, you need to key in the number of the note in case you have received this note, and people were participating in this. So basically, they were thinking, they're trying to see how these dollar notes were migrating across the United States, and people were reporting these dollar notes. So basically, the research was aiming at trying to figure out where the note was initially seen and then how far it has migrated. So we found that in user moment get explains to follow the power law distribution. Yeah, so the power law, typical power law distribution you can see in your right bottom corner. Then the trajectories show the high degree of temporal and spatial regularity. So basically, there's lots of regular patterns in terms of how people move in space and also in time. And this pro-human traveling behavior can be described by continuous time random walk process, right? So it's basically attempt of and a way to describe this mathematically, right? In terms of random walks. So like basically probabilistically and mathematically. So if we tie these findings back to location-based social networks, you can find that location has a new dimension to social networks. And this geotargeting, not just talking about the location itself, basically it's a place, but also about a very important factor as the semantics of location. So location is a new object inside the networks, and it bridges the gap between the actual physical and virtual environments, which is the social network itself. It's lets people share real world experiences online and let them consume online information in the physical world as well, right? So basically, when people are consuming the information about the type, popularity of location, physically being nearby, and making the decision to visit this location, then they go inside, they check in inside there, and then they contribute back to online so that other people have more experience on what this location is, and etc. etc. So this how it works, and examples can be in the physical world. Some person have posted the location, and then in the virtual world, you can see the corresponding activities has happened, right? So you can see what's going on there, what are the people there, etc., etc. And then it brings experience back to the physical world. So you can see that in the physical world, you can see that these people has been also checked in there. And then later you can see that in your virtual world back, you can see that, for example, number of people that have checked in inside these physical places have increased, right? So you can see more people there as well. And there's a lot of interactions happening between these, right? So people visit something, they check in, others see them, then it brings back to the virtual world. Inside the virtual world, it bounces back to the physical world. That's how this online to offline experience are coming together. So what can be done? There can be sharing happening. So people can geotag the media. Basically, you can geotag your picture, you can geotag your connecting your physical and digital environments. We can do more understanding about the interests and preferences of people, some location properties, etc. You can have one more dimension, like a geotag inside. Basically, it's one more object that get tracked. And of course, you can also have some social network components that we used to have in our social networks, such as users, locations, and the media. So this is four types of things that can be happening. So you can also split different location-based services into several categories. So for example, we have a geotagged media-based services, like Flickr, for example, right, or like Instagram. We can have point location-driven services like Foursquare, and we have some trajectory-centric social location-based social networks. And in a sense, our GPS tracking systems can be also attributed to this type of services. So you can see that the distribution, a couple of properties. So, for example, location-based social services can be split into more like in real-time updates or more like the type of information gets provided. So, for example, in real-time geotag media-based services, they are quite real-time, but the information they provide is very poor, right? So that's just visual content in a place. Point location is an instance, and they provide lots of information. Trajectory-centric not fast updated one, but then they provide quite rich information about the trajectory. So basically, this is the difference. If you talk about research philosophy of location-based social networks, you can see that we have users, we have locations. Users are connected to locations, and also there is a multi-modal content inside this trajectory that also connected one to another. So users communicate one between each other. You can build the user graph. You can also build a location graph, and then if you combine these two together, you can actually get a user location hypergraph. And inside this hypergraph, you can do a learning. It enables us to understand users better, understand locations better, and also understand events. So there is research in understanding users. For example, you can do user similarity link prediction, basically comparing people, recommending them to each other. You can look for experts and influencers inside the networks. This is how, let's say, in LinkedIn, they promote content of certain people, not just based on number of followers, but also rather on a way how influential these people are, how fast and much can get spread. And also you can do community discovery, so basically figuring out what types of groups of people and communities are there, and you can use it, for example, for marketing to target user group more efficiently. You can also understand locations. You can do generic recommendations by, for example, most interesting location or popular location, or you can do the iterative planning or recommend location activity recommendations. But also at the same time, you can do a personalized recommendations. For example, user-based collaborative filtering model, when we compare interests of one user to another user, and then they have similar interests, maybe recommend additional interest to the first user. And also you can have the item-based collaborative filtering, basically when we are comparing the items to users, basically location to person in some latent space. Then we figure out what kind of place is relevant to this user. Yeah, so this is how it works. We can also understand events. You can understand anomalies. You can understand crowd behavior patterns. All this can be understood. And one of the key applications of location-based social network is, of course, the vendor recommendation. So this is how it works with Foursquare. So the research in the bottom by NOLAS analyzed 35 million chickens over a period of 5 months in 2010. That time, chickens can be freely crowded from Foursquare. So basically, it's venues from across the globe, and it was accounted for about 25% of the entire Foursquare user base, right? So they got a lot of very popular and important venues. So the problem they were targeting is the problem of next check-in prediction. So given your previous check-in history, you are trying to predict where is the next check-in will be happening. So for example, if user check-ins in a flower shop on a Saturday morning, can you predict where she will go next, right? So this is a type of problem. It was a quite challenging problem because the class is very imbalanced. We don't go flower shops as often as we go, for example, Full Food. And it's very sparse. Yeah, so most of the users check in rarely, and there's a small number of users that really check in a lot. So there can be several venue recommendation strategy, right? So you can recommend venues based on the popularity, basically rank the places. We can do some content filtering, basically exploit venue type preferences. We can do social filtering, so we can rank places using check-ins by friends. So it's like collaborative user-based filtering, and also you can recommend based on the home distance. So this is, for example, coherent with the model of the opportunities model that I was discussing before. So given the user whose current check-in is C, we want to figure out or basically rank a list of the next venue that the person is going to visit and find the most high possible position in the list. And we, of course, the constraint L to be within the same city, right? So we don't want to try to recommend other cities because, of course, this is very unlikely with distant locations, and the space will be too huge to do accurate recommendations. So we always usually know where we are at the moment. They will come in up with some interesting features, user-specific features, basically historically where the person has visited, some friendship keys, preferred venue types, some geographical features, distance and grand distance, some place network, basically which places are related to which, and of course temporal aspects. And the feature vector for a current venue can be extracted based on these factors, right? And these are the factors that we were using. Basically, historical visits were not that useful in terms of the popularity. You can see that during the days of the week, which is an X scale, right? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, Sunday. You can see Saturday and Sunday, the places that people visit are different, and probably in the weekdays is a walk distance. But categorical preferences remain the same. Place popularity remain the same. Physical distance and rank distance remain the same. And you can see that place of the day and the place of the hour remain the same. And maybe place transition from one place to another, and also some social filtering. So basically, on the preference of similar people doesn't really work for this task. So predictions are more accurate at noon than in the evening. Predictions for physical and rank distances in reverse. Users cover shorter distance at night. Predictions for historical visits and place transition drops in over weekends, right? Because on weekends you go to different place, not in work, not in a regular place. Categorical place preference, place popularity, and distance-based features are more stable. And probably you can also add here that actually, if you want to profile people based on where they visit, this could be also quite useful. Location-based features can be also very good predictors for this type of task. This is a feature performance, and the results suggest that features tailored to specific user mobility patterns, such as historical visits or maybe social collaborative filtering, perform well for a number of places less than 16. And mobility features such as play popularity fail to achieve high accuracy scores for small n values. So basically, if you want to really predict the very nearest place and the person going to visit, just popularity of the place can be not a very good predictor. And indeed, if you are in a certain place and there is some super popular restaurant there, and you come to this place often, unlikely you'll be going to the place, right? You are more likely to go somewhere else that have less people and maybe have a more enjoyable meal, let's say. So they were using linear regression and 5-3 as evaluation algorithms, and F5 combined multiple features shows consistently better performance as compared to individual features. So all these features were useful. We'll come back to demography prediction in 3 minutes. So let's discuss demographic prediction and demographic mobility as the last topics for today. We have a demographic profile, and demographics is a backbone of our mobility analysis, right? We need it for planning the urban facilities. We want to do it for geo-dependent marketing and also geo-dependent advertisement. So if you have a guy and we know that he's, let's say, 40 years old and male, we can recommend lots of different applications such as marketing, wellness, advertisement, and assistance. So this could be the recommendations, right? This is what we can figure out about the guy just because we know his demographics. So this is very useful, and the idea is that different data, different types of data describe the same people from different views. So data from Twitter describes them maybe casually, from Foursquare talks about the location, from Instagram talks about the actual visual data that like basically like a visual view, right? So there are visual preferences, and together it's a multiple views. So ground truth for such privacy sensitive topics like demographics prediction is hard to achieve, and this is a challenge. People are rarely specify the age or such attributes as income are even harder to obtain. So this is one of the key things that are hard to achieve for this type of applications. But once you get that from about.me website, where, as I said before, all the social network accounts are aggregated about the brand, or from somewhere else, you can also train a very powerful models for data fusion that can predict this in a much better way. So there's a PAN evaluation where you can get some free data sets. And these PAN evaluations are happening every year. I even had one keynote there, so you can freely download data sets there and get some nice, interesting data to predict. But overall, let's say in 2014 and 2018, there were a couple of tasks that people were proposing. Task of plagiarism detection, task of author identification, and task of author profiling. So author profiling basically is given a document, you want to figure out what is author's personality traits. Author identification is a given document, you want to figure out who wrote the document. Plagiarism detection, basically whether this document was taken from somebody else. And inside author profile, they were also trying to identify age, gender, and personality traits, and this is quite interesting and useful. So if you want to identify, let's say, personality by data sets, you can try to see and look at it as one of the key interesting applications of user profiling. So the data set on PAN was Twitter messages on age and gender, and a couple of the key findings was there that, of course, for this kind of NLP tasks, when it comes to user profiling, the data preprocessing is extremely important, which includes case conversion, some character removal, spam bot detection. So basically, that what we discussed, like spammers detection, also spell checking, and another important thing. If another finding that researchers found in this PAN competition was that stylistic features are quite useful for the task of user profiling. So basically punctuation, number of words, correctness and diversity of the text. Readability features were quite important. Basically get some readability index. Content features were very useful. So like grams, Bible words, LIWC, lexical errors, and some second order representations were very useful. Classification model shows that random forests are very powerful in predicting people's personality based on the textual data. And some ensembles were very useful. So if you want to do age gender prediction, linguistic features that can be used as LIWC features that we discussed earlier, some user topics, and some heuristic writing behavior features. And efficient and effective method of studying these various methods can be considered as LIWC. So 74-dimensional LIWC vector that basically used to predict, to correlate with different personality traits, and can be used by the model to do a final predictions of the personality based on the textual data. User topic are also quite useful. So topics can be detected by, let's say, LTA models. So if one user is considered to be a document, and all the messages of this user are considered to be his content, and topics can be detected for the whole user. So given a collected set of tweets, you can generate, for example, 50 LDA topics and compute the word distribution among these topics. So it will be 50-dimensional feature vector for your machine learning models. You can also use writing behavior features, number of hashtags and slang words that we use, URLs, user mention, repeated characters, emotions, emoticon words, sentiment level, etc. Mistake, rejected tweets, misspellings, etc. So this all also can be used as additional so-called writing behavior features for your NLP task. But except for this, you can also extract the so-called venue semantics features from the location data. And this will be the distribution among different Foursquare categories that you can map and use in your machine learning model to do predictions. You can also use the so-called location topics, where you'll be combining many locations together, and then you will be using this to distribute every user among basically types of locations that they prefer to visit. So in an example on the bottom right, you can see the person U1 have visited a restaurant 2 times and an airport 1 time. So this is how it can get represented. So for Foursquare, as they have 764 categories for the data sets, you can also get 764 dimensional Foursquare venue categories and 6-dimensional location topics. And you can also extract the image concepts. So if people are running, you can see there's 2 people are running. There's also a tree, a house behind. So this is kind of all the information that can be leveraged by the image concept detection models, and then based on this information, you can further use this information to extract information on what are the visual components exist on your data. So by getting all of this, you can actually extract the visual data representation, you can extract the textual data representation, you can extract the location data representation. I think this I will be skipping the slide, but basically it shows that how the visual concept mining is happening, right? Remember that there was a SIFT features combined into better visual words and clustering to give you an image concept representation. And then you can unite all these features together to get something called multi-view representation or multi-view ensemble that is Twitter, Foursquare, Instagram, visual, textual, and location data together to predict the final score, final, let's say, age and gender, do the final age and gender inference based on the data. So this is some details of ensemble learning. So what you can see from here is that different modalities require different number of random trees by random forest performance, and also that we can have this called trans coefficient for each of the modalities, and basically this is part of this linear combination of different modalities to deliver the final performance. And as the result, you can see that, for example, multi-source ensemble can do a much better performance of age and gender as compared to traditional models, right? Or maybe data modalities, but separate. So multi-view models are actually very powerful. And these results are taken on the PAN data sets. We can see that multi-view data can actually help you to improve results as compared to, let's say, just text data. So This data set is available, by the way. You can get this data in the website NUS multisource.azure website.net. And this is as a result on the data set that the authors has collected. So the 0.8 accuracy almost in terms of gender prediction with a detailed breakdown among different types of sources. So you can see for the single source, actually surprisingly images were the most strong in terms of predicting based on both age and gender. Then if you see the for multi-source combinations, then image and visual components were better for gender, and for age, just text. All text features were more useful. Then, of course, altogether gives the best performance. If you look at geographic mobility as a whole, you can see that if you, let's say, split people not just based on the location, but also, for example, based on their gender, you can see that, let's say in Singapore, this is the map of Singapore, there are certain districts where only male users get chicken. And all these areas are usually some military camps. So this is like one way to split people. You can see from, like by knowing just gender, you can already see where males and females tend to go and where it's only male, only female groups. Also, based on the age, you can see that teenagers and children mostly prefer chickens housed in city areas and around schools. Students and working professionals are more towards the city center. So demographic mobility in Singapore can be very useful in terms of semantic profile. And if you look at the topics that were found in terms of this, like mobility topics or location range topics, you can see that there was topic associated with shoppers, with food lovers, with students, with teenagers, with professionals, and party goers. So it's a very distinct type of people with respect to every geographical location that they go. You can also see that particular users also differentiate from each other in terms of which topics they distribute, and therefore the basic principle of machine learning, like the ability to differentiate people one from another, also is here, and therefore we can do the profile recommendation services more precise. And this also split of topics among different ages and gender groups. So if you look on the region level, you can also see that, for example, on point number 3, there's a clear only female and only male areas, and there are areas where there's a lot of families living, so it's both male and female chickens. And also in terms of age, you can see that students and young professionals, they visit leisure during the weekends. So like long trips, and then adults, young people rarely go for long trips. They usually stay around the same locations. There is also an individual mobility. You can see that there's also such thing called personal mobility sectors. And from these personal mobility sectors, you can actually see how far particular people are going and what areas they tend to reach in their daily activities. So if you expand this further, you can detect something called business trade areas, and these business trade areas are very powerful in detecting mobility patterns of individuals. And they are used a lot in the business to do geotactic marketing, basically predicting where you tend to go, and then based on that, proposing you certain types of advertisement. So this is all very powerful, and you are greatly encouraged to use your final, to align your final project with this type of applications. It's not trivial, and demographics and multi-source data processing are basically a backbone of all these applications. So we propose the features such as topic learning, linguistic features, images for gender predictions, and locations for age predictions to be useful features for these applications. But of course, you can also predict occupation, personality, social status, detect communities, or do cross-region mobility profiling. And if you want to read a little bit more, these are the papers, including the Remstein's paper called Law of Migration. many others. So feel free to read and learn a little bit more about these interesting topics. While I would like to say goodbye for this week and see you next Friday. I'm gonna have tutorial now.